Hello everyone and welcome to today's session. So the first thing is Lambda expression iterating a list. Okay. So we have just created a simple list over here, numbers. We have added these numbers 1, 2, 3, 4, 5. And before Java 8, when we didn't had the Lambda expression. So this was how we used to iterate the list, right? So I've used here this for each loop. So I'm just iterating over it and printing the numbers. After Java 8, we can use the Lambda expression. So can you tell me like this for each over here that I've used, whether it is a stream method or some other package method? And what is the interface it uses? What I don't want to show you. What is the interface it uses over here?
Is a stream method and
Are you sure it's a stream method? I've not created it. If you see the
It's
numbers,
an it's
it's a
iterator's method from the
correct,
iterator.
correct. It's a iterator method. So see, this is a number. The stream methods can only be applied to stream of some data. This is list of integer, right? Not stream of integer. So there are two different data types: stream of integer, list of integer. Out of a list, you can create a stream. Out of a stream, you can create a list. Okay. So so for using that stream methods, you need stream data that you need to remember. Now this numbers is a list of integer, and on top I've used this for each, and it is a method of java.lang.iterable. So someone was correct who said this. And if you observe over here, it is using this functional interface consumer. So you have learned generics in the last session. So question mark super integer means what? It can accept what?
parent of integer.
Correct. It can accept parent of integer. Correct. Yeah. Okay. So if I run this, I'll be just iterating this. So I'll just quickly run and demonstrate. So this is how it looks like. Now let's go to the next one. So this is what Lambda expression executing method with no arguments. So this is your mathematical number. This is your interface with one. So is this interface a functional interface?
Till now, yes, without annotation.
No. If let's say you have a functional requirement that this should be a functional interface. So and you've already used it in Lambda. So if what is a good practice here? I have not followed that good practice. I wanted to show you.
Annotate it with functional interface. That is a good practice.
Correct.
If at all I want to make it a functional interface.
Yeah. And if I don't annotate it with, let's say, a functional interface, and tomorrow some other developer comes
and add anything, then it will break the implementation.
Correct. It will break here. So let me show this thing. So let's say, just for demonstration, I'm just quickly. Okay, this is method 2. So see, you have started getting compilation error over here. What it says, the type this must implement the inherited abstract method. Okay, so it is like here we have created anonymous inner class. But will this work even if I implement there? Let's say I implement that random number 2 over there, but still this will not work, right? This is the Lambda
expression is broken. Yeah.
Correct. So you cannot have you cannot use Lambda expression with non-functional interfaces. So the good practice is to have functional interface annotation on top of all your functional interfaces. Basically, when you add this annotation, now no one can do this. No one can come and do this. See, it will give you invalid functional interface annotation. Basically, it is trying to tell you that you cannot have more than one abstract method. Okay. Coming to this program, mathematical number. So here, what is this kind of a class? This is anonymous class. Okay. What is this?
Anonymous. Yeah.
Yes. So mathematical number is an interface. I am trying to instantiate a interface. So I have to provide its implementation by using this kind of a syntax, which is nothing but an anonymous class. So here I've simply just a random number. So basically I'm just printing a random number. So I've instantiated an object of random, and here I'm doing next end, and it is printing a random number. Now, when you create object of your interface by this way, So like can you like if you when you create that time, does it call the random number, or this is just like you're creating an object and then you have to call its methods? So see over here, I had to call the random number method. Just by providing the implementation, the random number method is not executed. I have to do this object dot method name, right? Correct.
Yes.
Yep.
Correct, correct.
So then it prints it out. Now this same thing, rather than using anonymous class, it can be done in much shorter. See how many lines of code are there over here: 1 2 3 4 5 6 7. And when I use a lambda expression for the same, how many lines of code are there now? 1 2 3 4. Correct. 4. 3 lines are reduced. Correct. So this is the difference. If you don't want to use the anonymous class, you can use the lambda expression. So this is nothing but lambda expression. Okay. So let me ask you this. When do you need this curly bracket in a lambda expression?
When it is more than one line.
Correct. If whenever there is more than one line of code, then you need. When there is only one line of code, you don't need this. All right. So if I run this, any guesses what will be printed? It's random, right?
And
We cannot guess it. Okay. So this is what is printed. All right. Going to the next concept, lambda expression executing method with arguments. So this is your calculate square. Again, here I have not annotated it. I'll just quickly annotate it with @ functional interface. And let's take this. Okay, so it has one abstract method, square of number. Now, again, like in the previous example that you had seen, this lambda method with no args, here the mathematical number method, it was random number. It didn't take any argument, right? It had no arguments. It was just a method, no args method, right? But now square number takes an argument. So how do you deal with it by using lambda expression? So this is how you deal with it. You pass the argument inside. Okay. You have to pass the argument inside. So I think in the video, there was some mistake in one of the code of lambda. So I've just corrected it. So you can refer this code. Okay. So before Java 8, again, you had to create anonymous class, call the square of method, pass the argument like 5, and it will print square of 5 is 25. Now with lambda expression, you are using this lambda expression over here. Rather than anonymous class, you're doing the same thing. Is how many lines? In 3 lines. So this is your method. So you don't have to mention the method name. Okay. Even if you want to mention, I think we can mention, but it is okay. So we cannot mention what it says. Okay. So I think we don't need to mention the method name. So I've seen that also, like we can mention in some way. So you don't really need to mention the method name. You directly pass the argument. So this is the argument, and you provide like what we will do with this argument. So what are we doing? We are multiplying that number with itself. So that is the square, right? If we pass 5, what will happen? 5 into 5, 25. So any questions still here?
No.
Okay, so this is clear, right? How do you deal with lambda expression with no arguments, with arguments, how you pass arguments? These things are clear?
Yes.
Functional interfaces are clear?
Yes.
Okay. So proceeding with the next one. So now you know how to use lambda expression for methods that have no arguments, how to create functional interfaces and why to create functional interfaces, and what happens if you don't annotate your interfaces which has only one abstract method and you've used it in lambda expression. And if you don't use the @ function, what happens? So these things are clear. These 3 topics are done. Now, yeah, functional interface again. So yeah, so this is a functional interface. COVID, immune, get vaccine. And just so this is how you can, instantiate. It's the same example what you've seen previously. Okay, so any doubt about this? This is pretty straightforward, right? This is your get vaccine method, and here you have provided the concrete implementation for that method by using the lambda expression. So we have created the object and you're calling the get vaccine method. Okay, so I think this would be very clear. Proceeding to the next one, inbuilt functional interfaces. Okay, so this is a very famous, like not famous, we can say very commonly used interface. Okay, consumer interface. So what is an consumer interface? It only it doesn't return anything. That hence the name consumer. It only consumes the object, right? So let's say I've created this person class. It has 3 fields: name, age, and gender. And it has all the, the all args constructor, getter, setter, toString, hash code equals, everything is written. Okay. Now I've created a consumer of person and I'm printing this person. Now what does this consumer, the object that I've created accept? So it accepts a person. You might be wondering from where where does this word accept comes from? Is anyone wondering this? Where does this method accept comes from?
Consumer interface, functional interface.
Correct. If you go inside here, you'll see that it has one abstract method accept. The name of the method is accept, and t is the nothing but any argument that you can pass to it. Okay, generic argument. You can pass any argument. All right. So this is again the generic syntax. You have to pass this t while creating the object of consumer. So that is what we have done. Consumer of person. So the accept will only accept person object. Okay. So when I run this code, you'll see the person. All right. So this is also clear. Now coming to the supplier. So supplier. So what is the supplier interface? What it takes, what it returns? Anyone? It's pretty straightforward by looking at this code. It's not taking anything, but it's returning something. So can I write sys out here and will it work? If I write sys out here, will this work?
With call addresses you can write, no? And you need to return, but
no. Can I, if I write sys out system.out over here and I print this line, I don't need input, but I provide output, will this code work?
Output will not be there.
no.
It will supply. It will not work because it is not returning anything.
Yeah, it should return something.
Yes, it should return something, so it will not work. So if you see the left side here, supplier, if you go inside it, okay, it is basically not taking anything, not taking any argument, but it is returning the argument of the instantiated type. Let's say you've created supplier of string. So this get method will return what? A string. If you say supplier of person, this get method will return what? Person. If you say supplier of integer, now can you tell me what this get method will return? What data type?
Integer.
Correct. So it doesn't takes any argument, it returns the argument. And what it will return is what you have to mention while creating the object of supplier. By using the lambda expression, we have created the object of supplier, and we are saying that it is a supplier of string, so it will supply us a string object. So here we have just used the lambda expression. We have called that method. What is the method name in supplier? It is get. So we have called this get method. You can imagine like it is written something like get over here. This is how it is. Okay, for your imagination, like how it is. Because I know for the people who are not coming from the Java background, they'll find it difficult to understand. That is why I wrote there get to make them visualize what it is doing. So here it is simply calling the get method, and by using the lambda expression, we are providing the implementation for that get method. So I'm saying that get method when called will return I don't need input, but I provide output. Now, once the object is created, I can call that get method over here, and this is the implementation. So it will return this. Now, writing here sysout will not work because since I am directly writing here, I don't need input, but I provide output. So this is nothing, but you can imagine something like this. Okay. It is something like this. So let me write you right here for your proper imagination what it is. So it is something like this. So you're providing implementation for get like this. Okay. And this is this get method. Inside this get method, you are returning this. So it is like string get, and this is what it returns. So now are you able to visualize what it is doing?
Yes.
We don't need to type the return keyword.
Yeah, we don't need to write it. It automatic. That is why Lambda and stream programming, stream was introduced, right, to have more of declarative. In Scala also, in a method, whatever is the last line of your code in a method, that is automatically returned. So that similar concept is used over here. The functional programming concept, like automatically infer what it will return from the last line. So we have finished till this supplier, right? Functional interface, the two simple interfaces. And let's come to stream operation. This is a little interesting. So, okay, so what are the stream intermediate operations? Distinct, map, filter, sorted, limit. And what are the terminal operations? Count, collect, for each, and one more is there, reduce. Okay. Reduce one I've put in the additional miscellaneous. Okay, so this is an example of distinct and for each. So let's say this is a list of strings, list of names. So these are the names: Samarth, Harshit, Samarth, Ankit. I want to get rid of duplicates. How do I get rid of duplicates? The simple answer would be convert a list to a set. Correct?
Yes.
But using streams, we can, do this in just one line. We can, do this name stream. Like what we are doing is first out of this list, we are creating a stream. Okay. So from list of string, we are converting it into stream of string. Okay. By calling the stream method on the list. So we can convert a list of string into stream of string. Now, once we have stream of string, now on this, we can call any stream methods. So what are the stream methods? This is a stream method, distinct. Once we call this method, it will filter out all the duplicates and it will return us all the unique elements. So it will be unique stream of strings. Okay. Now again, so this distinct, it is which kind of an operation? Intermediate terminal, which operation?
Immediate.
Yeah. So can you chain intermediate operations? Can after filtering, can you, after finding the distinct elements, can you do something like dot filter?
Yes.
Yes, we can do.
Yeah. So you can filter out, you can pipe, we can say, or you can chain intermediate operations. But can you filter, can you chain terminal operations?
No.
No, no. I
Correct.
won't say that.
Yeah. So once you use any method of the terminal operation, what happens to the stream?
Terminates,
There's
basically
no,
ends.
it's no more a stream. So
Correct. Correct. It's terminated. So it's no more a stream after that. Okay. So here I have this. Now this for each, can anyone tell me whether it's a method of a stream package or a iterable package?
no, this time it is a stream.
Correct. And why so?
No, yeah,
No, that is correct.
because
You are
it
correct.
is being called on distinct names, which is a stream.
Which is a stream of strings. Correct. So this time it is this. But if you observe that and this one, both are nothing but this interface, functional interface, consumer. Both are taking an argument of functional interface. You observe this? That for each was also taking argument as a functional interface consumer. This is also taking argument as functional interface consumer. So it's not necessarily like only these system packages use it. Even you can design some logic in your office where you can use the consumer interface, right? So this is done. So if I'll just quickly run it. So yeah, so this is how it looks like. So that duplicate Samarth has been removed from this list of string, and this is the non-duplicates. Coming to the next, stream operation map. So what is map used for? What is map used for?
To transform something.
Yes, for transforming one data type to another data type, or let's say for transforming one data into another type of data. So what is this example about? Here we have a stream of numbers. Okay, this is how you can create a stream of numbers. If you don't want to create like this, you can create an array list of numbers and then call the stream method on the list and convert it into stream of integers. I mean, yeah, stream of integers, we can say. The name is numbers here. And this is how you can even directly create a stream of numbers. Okay,
Yes.
remember this method. Like, this is how you create a stream of numbers. Now once you have stream of numbers, we can perform any stream operation on it. So what is a map operation? It's a terminal operation or intermediate operation?
Intermediate.
Intermediate.
Correct, it's an intermediate operation because on the next line itself we have used a terminal operation. Okay, so coming here, so can I combine these two lines into one line?
Yes, I think.
Dot map dot for each, right?
Yes.
Yeah.
So yeah, we can combine. So why do we need it on separate? So that was for your explanation. And let me just make it like this. Okay, I have to remove this. Yeah. So it's now a single line, right? So we just wanted to print, right? So why we need two lines? So what we are doing here is we are just taking a square of the numbers, right? We're taking square. So 2 into 2 is 4, 3 into 3 is 9. That is what we have done over here. So using the map, we have calculated the square, and then using the for each, we are printing out the result. Okay. All right. So coming to the next example, stream operation filter demo. So what is filter used for?
To do some operations on the input and to filter it, probably out of the list take few numbers according to the condition that you pass.
Correct. Just for filtering, simply for filtering out. Like here in this simple example, we are just filtering out which numbers? Even numbers. Using this logic, we are saying num percentage 2, or we can say modulus. So if the remainder is 0, that means it's a even number. So we are returning this stream of even numbers, and using the for each, we are just printing those list of the even numbers. So can we combine these two lines like we did previously?
Yes.
Yes, we can combine. You can try that out later on. Coming to the next example, stream operation limit. Okay, so what is limit used for? Let's say we have some 1000 numbers, out of which we want to process only 100 numbers, so we can say limit of 100. Correct. So limit is used for limiting the numbers. Okay, now this is nothing but a truncated number, so we have taken only first 5 numbers and we are printing it. Okay, coming to the next one, which is count. So what is count used for?
Count the numbers and
Correct.
elements in
Yeah,
it.
simple, count the numbers.
Yeah.
So yeah, so it basically says there are 8 elements here. So if you see, you have
7 missing. Okay.
yeah, 7 is missing, so there are 8 elements. Correct. Even I got confused for a moment. Okay, so coming to the next one, sorted demo. This is a list of names, and let's say you want to sort it. So by default, when you call this sorted method, it will sort in which order? Natural order. Natural order means ascending order or descending order.
Ascending.
Correct. By default, it sorts in ascending order. I'm going to demonstrate how you can sort things in reverse order also, means descending order. I have those examples ready over there. So let me quickly run this. Let's say you want to filter and you want to sort. How will you do it? You want distinct.
Dot filter first and then dot sorted.
Really, like, I mean, distinct would also work, right? I want distinct elements.
Yeah.
Then duplicate is gone. Coming to the collect demo. So collect is a terminal operation, right? So here, what are we doing? Out of this stream of integers, we are using the collect method, and we are converting the stream of integers to a list of integers. Now, if you want to convert this list of integer back to stream of numbers, how can you do it? Anyone?
Same we can do number list dot stream.
Correct. Number list dot stream. So that is how you convert number list dot stream. That is how you convert a list of integers to a stream of integers. And using the collect method on stream, you can convert a stream of integers into a list of integers. So you need to remember this, the how you convert from stream of integers to list of integers, from list of integers to stream of integers. Okay, this you should remember. Okay. All right. So proceeding to this data API, I'll close all tabs. So local date time API. So this. So using the now method, what it prints? Local date time dot now, what it prints? Does it prints current time or it prints current date time?
Current date time.
Correct. It prints current date time. So in that video, it was written. I mean this. Let me change this so that it's properly reflecting what it's printing. Okay. And using the get month, what it will return?
The current month.
Correct. During if you call this method plus days 300, what it will do to the current date time?
It will add 300 days.
Correct.
To the current date.
Yes, and then you can print it. You can get the month also. Then if you want to find the local date time for some past date, how can you do that? You can use this local date time dot off method. It will return you local date time for some past date. Okay, some random date. So here I've printed I've given, so it is like this. If you place your mouse over here, first is year 1995, then is month, so it's August, day of month is 11th, and hour is 3, minute is 15. So this is how you can create a particular local date time object for some random date. Now I'll quickly print this, run this code. So this is how the output looks like. You have date, then you have time. This is the month, get month. Future time, when you added 300 days to the current date time. Future month is May. Local date time is this. Okay. So let me ask you a practical example. When will we use this kind of a method, plus days? In practical scenario, can you just think of an example?
To identify maturity date of any trade booked.
Correct. Let's say you have created an FT. Someone is creating an FT. So their code will come, the UI will redirect to your code. Okay. And there you can add this logic. And let's say that FT is for 1 year. So you can just, add that 360 days there, right? Correct. You can just do that plus days. And you can create that the time when that FD expires, fixed deposit, or maybe insurance. These kind of things. For expiration date, you can use this plus date, right? From the current date. Correct. Okay. Coming to zoned date time API. So this is again the same thing, only what you were doing with local date time, but the difference is here you can, when you're dealing with multiple time zones, so this will be useful. And so in that example, he has shown you zone ID of Europe, Paris. But if you want to see, of other regions, this is the Oracle page where you can see. So let me just show it quickly. So here you can find the other values also. So I don't think this here demonstrated. He just picked from that zone date time page whatever he found. But this is the page. I've added this page link so that if tomorrow you work in such a application, you can just refer this link quickly from this code, and you can change your zone ID accordingly. So I'll quickly print this out. So from Asian time, I now have this, I mean the European time. Okay. I mean, this is some random date I've used. I've just created random date time, and I'm setting the zone ID for that as Europe Paris, and creating object of zone date time, and just printing the zone date time. So by default, I am in India, so it is like my date time is this Asia Calcutta. Okay. So now we'll start with the miscellaneous topics. So here I've calculated square of number again, but in single line. Okay, so in single line, I have used first map, then collect. Then I've returned a list of number. So this is clear, right? How it's working. If I run this, it will give you square of number. So I've done this work in one line. Okay. So this for each again, it's a iterable java.lang iterable package method. Okay. So why can't I use dot for each over here after collect? Can anyone tell me that?
Because collect is already terminated.
Yeah.
It's
Yeah,
a terminal operation.
correct. It's a terminal operation. So whenever you use any terminal operation method, what it does is it terminates the stream. Once the stream is terminated, it's no longer there. So you cannot use any stream method. So that is why I've used this other method over here, the java.lang.iterable one. Okay. So this is clear, right? Now let's say, see, if I show you now, so it will give some error over here. So here you can just try this out, but it will give you error because
But I
this,
think here this for each should be taken from iterable. Will it not work?
see, this will not work because the stream is already, see, it says cannot convert from void to list of integer. So iterable can only work on list of
But if you will remove that equal
collect.
to thing, then I think it will work.
Where?
No, 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 no.
No, it will not work now, because see, till map, it was an intermediate operation. Whenever you have an intermediate operation, see, if you place mouse over it, you'll see that it returns what? It's returning a stream of integer. Correct?
Yes, yes, yes.
But this collect is not returning anything, right? This collect, what is it returning? It's returning list of integer, not stream of integer. Correct?
Mhm.
So if you're getting list of integer, so can you use any stream method? So for what is the condition for using any stream method? The data on which you're using should be some stream of object, right? Stream of integer, stream of string. If it's a list of integer, you cannot use. Now over here, if you want to use, let me show you some more complex thing. If this collect is returning me a list of integer, right? Take this to another line, comment this out, comment this out. Now in one line only, I want to print also. I don't want to collect, but this is I'm going to show you a very bad way of writing code, but it's necessary that you should know. Let's say in this line only, you want to print out using for each. How can you do that?
And we typecast it to list of integer and then do
No,
dot.
you see, this is already returning you list of integer. This is already returning you list of integer.
Yeah.
Now you have list of integer. So how do you convert a list of, let's say you want to use for each of what you want to use for each of
Iterable.
no, iterable, you have to first take it outside and then use it. So let's see, can we use so if we are using this for each, yeah, so iterable also we can directly use, it seems like. So yeah, so I want to show you something more complicated. Now if I'm using this for each should be from iterable. Yeah, so it's
Yes.
from iterable. This is how it will work. And let's say someone else has written this code, okay, the above code, and you're not allowed to modify that part, but you can change, because let's say the map object is map logic is very complex and you cannot touch till here, and you want to perform some further processing out of what output you're getting from collect. So how can you do that? You want this in same line only, how can you do it?
Again, stream off, but that's
Dot
really hard
stream
to know.
again.
Yes, this is how you can do it. Let's say I want to filter out after multiplying, I want to filter out even numbers. So this is how I can do, right? Percentage 2 is equal to 0 dot again. Now I can print it out, right? This is how I can do.
Mhm.
See, 4 and 16. Correct? I'll just keep this for your reference and revert the code because this might look very complicated to other guys who are from non-Java background, what we just did. I've copied it. I'll paste it below for your reference. Okay. So I'll just paste whatever you've learned over here. Okay. You can go through it anytime. Okay. This was a simple example. For people who are finding that complex, stick to this for now and slowly you will get to this level. Okay. So the simple thing was this, like we were calculating the square of numbers, okay, by using the map, and then we were collecting it, and then we were using for each of iterable, and we were printing out those elements. Okay, so you've seen square of numbers. Now filter and collect. So again, here I've just created a list of names, Sahil, Saif, Shijit, and I want to filter out names that starts with S. So we can do it with this way. So it's a list of string. So in the filter, I say S dot starts with, it's a string method, right? It's since it's a list of string. So using filter, what it will do, it will take every object of string and you can perform some filtering logic on that. So I say the name dot start with S. So any name that starts with S, collect it, correct? So this will give me all names which start with S. And here I'm just printing names with first character as S. So it's just filtering out Sahil and Saif. So any doubt still here? Or should we proceed to the next one, next example? Okay. So sort and collect. Okay, so this is how it is demonstrated how you can use sort and collect together. So this is a list of, I mean, the names Sahil, Saif, Shijit again, and I want to sort this list. So this is the natural way of sorting. I take these names, convert it to a stream of strings, then use the sorted method. It will sort the stream of strings and return me again a stream of strings. And then I collect the collect basically, I basically convert that stream of strings to a list of streams with this collect collectors to list thing. Okay, this is what I'm doing. And then using the for each of iterable package, I'm printing it. So this is sorted. Okay. Any doubts still here? So have you understood what we have done here, how we have combined sort and collect together, and why and how it's working? So stream is the start operation, right? Any start of a stream operation. Sorted is intermediate operation. Collect is terminal operation. Correct?
Mhm. Yeah.
Okay. Sort in reverse order and print names. So till now you have seen how you can use the sorted. So it is sorting in the natural order of sorting. Natural order means what? Ascending order. Let's say I want descending order. So I need to use this comparator. So in the sort method itself, I'm just writing comparator. Okay, this comparator is from Java util package dot reverse order. I'm calling this method. So it will return me, it will sort the stream into a reverse order. So now I'll have reverse order sorted over here. Okay. And this was, okay, so this is from Java 8 onwards, you can use streams, right? So before Java 8, this was the method. So here you'll find like without using streams, it is much simple to, do this sorting, right? I'm just using the sort method on the list. So list is also providing a sort method. Stream is also providing a sort method. But when should you go for sorted method of stream over sort method of list? Can anyone tell me?
Any chaining?
Yeah, for chaining you should use stream, and when you're using stream you have to use this sorted method for sorting, right? And when you don't have this any complex logic, you have very simple logic, then go for this normal way of coding before Java. Okay, so going to this, remove duplicate names. So this is a list of names and I want to remove duplicate out. So yeah, there are two ways, right? I can use either stream.distinct and then collect to a list, but what is a simpler way? What comes to your mind? To convert it to a set, right? So I've just written an example here how you can convert a list of names to a set of list of strings to a set of strings, or we can say list of names to a set of names. So we know, right, that in a list there can be duplicates, in a set there cannot be duplicates, correct?
Mhm.
So simply I have converted this list of names into a set of names, okay, unique names. So the logic is simple. You just convert it with dot collect, and instead of two list, you say two set. Okay, so is this clear?
Yep.
And then I'm simply just printing it. Okay, so I've removed that duplicate sef from the names. Okay, find square root and print. Okay, so this is again that example. So this map is an intermediate operation. So I'm just taking this number, converting this number, which is nothing but list of integer, to a stream of integer by using the stream, by calling the stream method. You can see it's returning a stream of integer. And then I'm calling map on it, and map again returns a stream of integer. And what I'm doing is I'm finding the square, and then I'm just printing that calculated square value. Okay, so is this clear? So all the stream operations and how you can chain it, is that clear? Like how you can chain it and what you can chain and what you cannot chain. Okay, so can anyone tell me what operations you can chain and what operations you cannot chain?
Intermediate operations can be chained.
And what cannot be chained?
Terminal operations, once it's terminated, we can't chain it.
Correct. So now I think you have good hold on the streams, and this is some additional things that I wanted to show you. So there is one more terminal operation, reduce. Okay, so get all even numbers and add it and return the resultant number. So till now you have just filtered out and collected some collection class, right, by using stream. So let's say I want to find all even numbers from this list of 2, 3, 4, 5. So what are the even numbers here? Anyone?
2, 4.
Correct. Now I want to find the even numbers and add the even numbers and return the result. So what will be the result of this list of number?
6.
Correct. It will be 6. So I'm streaming over it. I'm filtering out the even number. And then in order to add all the event number, I'm using reduce. Okay. Now here's the good thing that I want to show you. So if you see reduce, so this reduce is taking what? It's taking an integer and the name is identity. It's taking a binary operator of integer and the reference name is accumulator. Correct? So if you go inside this reduce, and so if you see this, whatever identity you give, this has to be same T and T. It's not T and B, right? The data type of this variable, first argument and second, the binary operator of it should be same, correct? Now, if you go inside this binary operator, it is a functional interface, okay? And so which functional, the binary operators, which method are we using over here? Which is this method? Can anyone tell me, like, after looking over here? So do you see any abstract method here? It is having this min by,
It will
max
be
by.
in by function. I guess.
Correct. By function. So this by function can take three
Apply.
different things, right? It can take two different kind of argument and return a third kind of an result, right? So what's the method name?
Apply.
Apply. It takes t and u. Okay. Now coming back over here. So what will be assigned to ANS integer? What will be the first value that will be assigned? 0. Okay, so that is what it does. It assigns this identity value to this integer. It declares internally integer answer equal to 0, and then it iterates and applies this logic and keeps adding. So first will be 0, then 2 will come because 2 is an even number. So it will say 0 plus 2, 2. Then 4 will come. So answer is now what? Answer is 2. So it will say 2 plus 4, 6. So what will happen? So I've explained you the logic. Let me just run it and show first. So see, it's printing 6. What will happen if I make this from 0 to 2?
Yeah.
So it's answer, the value of answer. It is like as good as like you want to add some numbers. Okay, add a list of numbers to, like you have 1, 2, 3, want to add that. So it is like 1 plus 2 plus 3. You write a for loop and you create some int sum equal to 0, and then in that for loop you do sum plus sum equal to plus that value of I, right? Int I, whatever it is. So the same thing you are doing here. So instead of 0, if you write here 2, it is like int answer equal to 2. It starts with 2. So it will be 2 plus whatever the x value comes from here. So x value comes as 2. 2 plus 2, 4. Now 4 comes here. So it will be answer is already 4. 4 plus 4, 8. That is what is happening. Okay. So is this clear?
Where is that recursive method implementation? It would be in reduce, no?
Yeah,
Okay.
I mean that is how the stream is working. It's there is no recursive method, I feel,
I
but
mean
it's like
answer plus x. It must be doing recursively. That's what I meant.
if I try to see, I mean, no, I don't think there is any recursive because we are only writing the logic of that bifunctional here, right?
Okay.
So
It
it
is
is
kind of same as map, no? Meaning each element will take and then will.
correct. Correct. It is kind of same like map. We can say
Mhm.
that. Yeah, there's no recursive method. It is not calling itself again. I mean, it looks like that, but it's not. It's simply like a kind of a for loop. So inside this filter you have, it's your filter is like your if condition, and inside this you have this thing. And when you're doing this stream, it is like a for loop, right? You're just
Yeah,
iterating over the numbers. So you're
yes.
inside a for loop, you have this if condition, and you have this logic in which you are just adding the numbers based on your if condition. Okay. The base concept is that whenever you want to return a single value and out of a list of value, then you use this. Okay. So let's say you're working on some trade data, and out of some stock list you want to find out, let's say stock prices you want to find out an average price. So you can an average price, and let's say sum of 3 average prices over 3 years. So you can do that with this reduce, right? You can write that logic in this reduce, but it won't be this simple. It will have these curly brackets, and it will be multi-line logic, right? Correct.
Yes.
I think you need to use the word return.
Yeah, then I think I need to use if I add that multi bracket, then I need to use the word return.
Mm.
Yeah, right, you're saying this. So
Yes, yes, yeah.
okay, so actually writing the word return is going back to the imperative way of programming.
I mean, if we are using that curly braces, then
Yeah. So okay, so this concept is clear, right?
mhm.
So let's proceed to the next parallel stream demo. So here what I'm doing is I'm reading one actuator JSON file from my local, and I'm converting this file to a stream of strings, and then I'm reading it. and then I'm simply printing it. Correct? So using the parallel word, what happens? So when you read it, so parallel is again a stream package method. Okay, base stream parallel. So you can see over here, it's a stream package method. So using this parallel, what you can do, what you cannot do with stream. So till now, whatever methods you have seen, okay, it utilizes only one core of your CPU. Okay, are you aware of that?
Yes, yes. Can you
It does
please?
a sequential operation. So whatever you have seen over here, it was a sequential operation. It was processing one result at a time, right? It was taking this to filtering it and then doing this. Once it has completed for 2, then it was taking 3. Once it has completed for 3, then it was taking 4. And once it has completed 4, it was taking 5. But the difference with parallel is that it parallelly processes it. So it's much faster because it utilizes all cores of your CPU. Okay. So let's take this example of reading a file. So for this file is your Java IO package. What you had studied theoretically here is the practical example for that. We are reading this file and we are just, converting it to a stream of string by using this files.line method and passing this path. Okay, whatever we have here. So this to path basically returns what? So it returns a path. So, okay, you need this kind of a syntax for reading a file. Then we are calling the parallel method on the stream of string. Correct? Is this clear? Like what we are doing? And then we are printing the content of this actuator.json. Let me show you the content of this actuator.json. So this is the content of that actuator.json. Okay. So these are the things. So will it read it sequentially or will it read it non-sequentially?
Should be non-sequentially, I think.
Actually, it should be
Parallel.
non-sequential. That is what documentation says. But here are my observation. I find it read sequentially. Maybe it's a small file because of that.
Yes, it uses actually fork join again, fork join pool, and it it takes on load and all, meaning it will be.
Yeah, internally it might be using fork join pool because that is for parallel processing, right? For utilizing multiple cores.
Yeah.
But here you can see it is reading sequentially, but on the documentation it says it reads unsequentially. For this example, it was working this way. Even I don't know why. But for this example, read file and save it to a list. It was reading non-sequentially. Okay, so I just created another example to try this same thing out. For this JSON file, it was somehow reading sequentially, but for this text file, it was not reading sequentially. So these are my observations. Okay, so you can see this list text file. See it carefully. First is SG, then is MS, then is JPMC, then is Goldman, then is SSGA, then is BNP. Okay. Remember these three sequence, first SG, then MS, then JPMC. Now I'll run this file. Okay. So it's simply reading that text file which I showed you, converting it into a list of string, and then printing that, the list of string with this parallel stream method. So you can even call the parallel stream method on a list of string, and this gives you a stream of string. Then we are using the for each and printing it. So if I run this, you can see the sequence is changed. So it's like Goldman first, then SG, then SSGA, and the sequence in file was SG, MS, then JPMC, then GS. So the sequence has changed. Correct. So if I take this over here, now you can compare the sequence. The sequence in which it was reading, it has read in a random order. So why is it reading in random order? Can anyone tell me that?
Here, parallel stream is complete different implementation, and parallel is an implementation, a method on a stream. Or is it not?
No, actually, on the official documentation, it was saying this should also return in a random order, but it was not. So I just created this example, another example to try the same thing out. And I found out like in JSON file, it was reading sequentially, even though we have used parallel, but in text file, it is reading this. I mean, as an experiment, what you can do is you can take this piece of code, okay, what I've written here, same way, like we can do it right away. So
Otherwise, just
And
take the
there,
JSON file path and put it there. That also we can try.
yeah, so I'm going to try that only. I mean, in JSON file, vice versa, right? You're saying. So
yes, that we can test. Meaning, so there is two things, right? Read all lines here and then read line there. Meaning, read or something is there.
I think read
Lines is
lines,
there.
but yeah, read all lines and lines. So this is like
Same is it?
two different methods actually. This lines is returning you a stream of text, and this was returning you a list of string. Okay, so let's try this same thing over there. Okay, this same thing. I'll just copy these things and let's comment these things out. So let's comment this also and this also. Let me just minimize this. Okay, so this is my file name. I've converted to text parallel stream. Okay, let's run this code and see. Yeah, save it. Okay, so yeah, it seems like when you read in this manner, it reads in random order. And when you read in this manner, so it reads it parallelly, but it prints it sequentially, right? If you see the output,
Can
it
we
is
change the
random.
last line to text.stream.parallel and then see? Just the last line, yeah. Instead
So
of
it
parallel
is,
stream,
yeah.
text.stream.parallel.
So it seems something related to this, it seems. The read all lines.
Yeah.
Reads all lines from a file. Bytes from the file are decoded into character using this. So, but parallel should do the parallelism. It seems like this is doing kind of, right? Because it's still printing in random order. So that is, so if we use read all files, it prints in random order. When we use lines, it prints in sequential order. No matter what stream method we use, parallel stream on list or stream dot parallel on, list again. Yeah. So any questions so far? So this is just the R&D that we are doing, right? This thing.
Yeah.
So any questions so far on any of the topics that you've learned? We still have 7 minutes. If you have any doubts, questions, please ask.
Hello, Samarth. Sorry, actually, I was just went for some time. Just can you summarize the last one?
Yeah. So when we use, these are the observations that we have just done right now. Okay. So when we use this line number 20, okay, files dot lines, and then we use this. So it was having sequential read. Okay. So I'll just demonstrate quickly. So, so this is this why I just need to call this. Okay. So when we were using this lines, it was having sequential read. So you can see that it is a sequential read, right? The way the content is in the file, the same way it is got printed here.
Okay.
Now, when I use, where is it? Okay. So now when I use this way, read all lines instead of lines. Okay. When I use this read all lines, and instead of, let's say, parallel stream, even now if you use that stream way only, okay, what we were doing previously also, we had used this, right, parallel. Now once we do this, now it's non-sequential, the read is non-sequential. See, you can see it's up down. So lines are read in non-sequential
Yes,
way
yes,
because it
yes.
is run in concurrent way, we can say. I think the parallel thing reads it parallelly, but if you directly have reading the file to a stream, you can read it parallelly, sequentially. But if you're reading file to a list, then converting the list to a stream and then trying to read it parallelly, then it will, I mean, then it will be non-sequential, and you'll get that kind of mixed result. But both of them will have parallelism internally.
I think Java people, they tried to implement this parallel stream onto a stream, but however they already created one parallel stream
Correct.
on collection. I mean, I think we can achieve the same thing using dot parallel on a stream object.
Yeah, so it is like
Maybe,
we can
I
say
don't.
like parallel stream could be a helper method, right?
A parallel stream itself is like a full implementation like a stream.
If we, let's see that. Okay, so this is list of string. I want to use first I want to, okay, so I want to use that parallel stream.
Mm.
Now let's go inside this. So it is returning a stream of this. So stream support dot stream. It seems like an okay, class only it is. And return new reference pipeline. So yeah, I mean, we can just, do some more R&D, get into this source code and try to figure out how it's doing. Okay, so we need to be careful while we're using these kind of things. If you want sequential output, go for this. And if you just want to, you don't want to maintain, let's say, the sequence in which you're reading, you just want to, read each and everything and process certain, I mean, you don't need to maintain the sequence in which you have read. You just want to process each and every line and save it to a database. Then you can use parallel stream. I mean, this read all lines method, right? That would work. Let's say your stock data in which you have your stock price, the upper circuit, lower circuit data. And so you want to process every row, but you don't want to process in the order the stock data has arrived. You can process it in random order and store it in, I mean, random order in your database. You just need the processed data out of it. Okay. Then you can use this. But if you want sequence in which the data has arrived, you want to save the sequence also, then I would suggest use that read this lines method, which gives you directly a stream of data. Correct? So is this example also clear?
Yeah.
Okay. So that's it for today.